Hello, now that we know what an arithmetic sequence is, today we're going to look at something called an arithmetic series. Very similar, but there is one difference between the two. So let's start with our definition. What's an arithmetic series? Well, it's going to be the sum of the terms that form an arithmetic sequence. So an arithmetic sequence we've been working with the last couple lessons. So 2, 4, 6, 8. Who do we appreciate? Still not funny? Okay, so that is an arithmetic sequence in AP. It's adding 2 to each term. So we see the pattern, that is an arithmetic sequence. Now, if we take the same pattern, but instead of commas we put a plus sign, then we now call that an arithmetic series. So that's the only difference. A sequence is listing the terms. Series means that you're adding the terms all together. But in terms of T1, D, N, all of that is the same. So it shouldn't be that hard today. If you've been doing your work on arithmetic sequences, today on arithmetic series isn't that bad. So we have 2 new formulas. So if you go back to the salmon colored sheet, we've been using the general form for the last couple of classes. Now you can see the next 2 terms have S's by them. So S stands for sum. So we have 2 formulas on the sheet. So the first one, Sn is equal to n over 2 times T1 plus Tn. Again, you wouldn't have had to memorize these even if we were in class. So when you're doing your work, please have your formula sheet out with you. You'll naturally memorize them because you use them so much, but that is not required for this course. So S just stands for sum. So to get the sum, n still stands for how many terms you have. T1 is still the first term, and Tn is whichever term we're talking about. Now, just to show you a little bit of a math here, if we take this formula, we can replace Tn with the formula we had yesterday. Why? Because we can do that. We like looking for patterns in math. So what if we replace Tn here with our equation from yesterday? So what if we make T1 or Tn T1 plus n minus 1d? Well, if we just stick that into the formula and clean it up, you would get T1 plus T1 is 2 T1s, and that's your n minus 1d. So the point of all that is we have 2 sum formulas. They are both given to you on the sheet. You don't need to memorize them. But why do we have 2? Which one do we use? Well, it technically doesn't matter. They should both lead you to the exact same answer if used correctly. But I'll just show you the examples. Sometimes it'll be easier to use one or the other. Okay, so let's try a couple examples using the sum formulas for arithmetic sequences. So the first example, determine the sum of the first 25 terms of 3 plus 5 plus 7 plus ... Again, when you do your hand in, we do realize you could just figure out the pattern and then take a calculator or mental math and add them up and get the sum to the first 25 terms. You technically don't need a formula. We are aware of that. But that's why we'll have the word algebraically on your hand in. If you were writing your exam, in test, in class, they would all say algebraically, because the point of this unit is to know how to interpret these formulas, not just expand and count. So that would be more of an elementary method. So we're building up in pre-calculus to know how they fit into these formulas. So let's analyze what we have. Our first term, T1, is 3. N, we know, is 25. They told us there are 25 terms in this arithmetic series. And the D value, they didn't tell us, but we can realize that we're just adding 2 to each term. Okay, now we want to get the sum of the first 25 terms. So that's what the S stands for, sum. So S25, what's the sum of the first 25 terms? We know that N is 2, or not, N is 25, sorry, N is 25. These 2's are part of the formula. We were given that the first term is 3, N minus 1, 25 minus 1 is 24, and our D value is 2. Oh, our D value is 2. I said it again, but I didn't write it correctly. Our D value is 2. Okay, and then we are just cleaning it up a bit. 25 divided by 2 is 12.5. This gives us 6. This gives us 48. Oh, I'm going to run out of room here. This gives us 54. And if we multiplied everything to correctly, we should get that our sum is 675. Can you still see that in the video? Yeah, I just made it. You can still see that last line. So S25 is 675. You would have gotten the same answer expanding without a formula, but that keyword algebraically means that we need to see the formula and the steps to get to that. I'm just going to solve it again, but show you how we get the same answer using the other formula. So I chose to use the second formula on our sheet. Even though it looks a little bit harder than the other one, it actually was pretty easy because the question gave us T1, N, and D into it. So let's just redo the question. because I know that this formula looks easier on the formula sheet. So we would know that n was 25. We were given our t1 value was 3, but the problem is we weren't given tn. So even though this formula looked easier, if we tried to use this one instead of the other one, we don't know tn. So that's why it was easier to use that first formula, because all those values were given in the question. But let's say you really like this formula and you wanted to, I'll just show you how you would solve it. So if you wanted to use this formula, you would have to add a second step. So first, you'd have to go back to the formula from last class, Tn equals T1 plus n minus 1d. We were told that T1 is 3, we know that n is 25, so minus 1 is 24, and our d is 2. So if you insert, you would have to solve for your Tn value first. Now you can go straight to the formula. So n is still 25, our T1 is still 3, this is 51, and if you try it out, we would get the same value of 675. So like I said, when there's two formulas, they both lead to the same answer, but if you chose this one, you would have to do 2 steps. Solve for Tn first, and then go to this one. Whereas if you use the other one, there's no pre-step, you can just insert and solve right away. It's personal preference, whichever one you like better. Okay, so that's just how we use the two formulas. So for our final example, we're going to do this one. Determine the sum of 8 plus 12 plus 16 plus ... plus 100. So again, we're going to use one of the two sum formulas, but here's the tricky part. Both of them do require us to know the value of n. So looking at what they gave us, our first term is 8. The d value is not given, but we could tell we're adding 4 to each one. This time we do know Tn. We do know Tn. They tell us that Tn is 100, but we don't know n. So unfortunately, both formulas do require the value of n. So we have to make this a two-step question. We can't bypass it. Regardless of which one you use, you have to go back to last class. Tn equals T1 plus n minus 1d. You have to solve for n, and then you have the choice of which formula you want to use. So no shortcuts to this one. So again, we know that Tn is 100. We know our first term is 8. We do not know what the n value is, but we know d is 4. Again, there's different ways you can rearrange it, but I'm going to subtract out the 8 first. You can distribute the 4 collect like terms and bring it over, but I'm going to divide the 4 out first. Like I said, just personal preference. I just avoid the step of distributing. So 92 divided by 4 is 23. Now again, be careful. That gives us n minus 1, not n. Sometimes students stop and think the answer is 23. Or they'll subtract, they'll think it's 22. Remember, you would have to add 1 to each side, so our n value is 24. Okay, we have to do that step regardless of which formula we're using. But now that we know our n value, now we know all the numbers we need. So you can use whichever the two sum formulas you want. I've chosen this one because it's shorter, but if you like the other one, go ahead. Regardless, we know the n, the t1, the tn, and the d for both of them, so both of them work. So if you don't like this one, you can go back and use the other one. 12 divided by 24, oh, I said the answer. 24 divided by 2 is 12. We have 108, so 12 times 108 gives us 1,296. And if you don't like this formula, you like the other one, try it, and we should get the same answer both ways. Okay, so today we're doing arithmetic series, so we're using the sum formulas off of this sheet. Okay, good luck and have fun.